Okay, number 190 in your classwork for imaginary numbers asks to select all the appropriate cells in the table where the product of the two numbers is a real number. So we cannot have an imaginary component. We cannot have any term with an I in it. So this means that for the product of 7 minus 4 and 2i will give us 14i minus 8i squared, and even though the minus 8i squared, that I squared will become a negative 1, turning that into a positive 8, we still have that 14i in the front of that positive 8, so this cannot be one of our products. Okay, looking at this 7 plus 4i, okay, we'll have a product of a sum and a difference. So writing this out on the side, so we'll have 49, then minus 16i squared, and yes, this I squared turns into a negative 1, so we'll only have real components here. So this means that this is a solution here. Okay, then just multiplying by a constant 5 will do nothing for us because we'll have 5 times 7, which will be 35, but we can't get rid of this minus 4i, and that'll just turn into a minus 20i, and there's no way to get rid of that, so no. Multiplying negative 3i and 2i, so we'll have negative 6i squared, and that I squared turns into a negative 1, so we'll have 6, that's good. Negative 3i times 7 plus 4i, so we'll have a hanging negative 21i when we multiply negative 3i and 7. And we get rid of the I when we multiply by 4i, but we can't get rid of that minus 21i, so that's a no for that one. Then multiplying by constant 5 also does nothing because it just turns into negative 15i, so no. Going on to negative 8, so we have negative 8 times 2i will give us negative 16i, no thank you. Then we have negative 8 times 7 plus 4i, so we'll have 56 plus or minus 32i. I can't get rid of that 32i, so no. And negative 8 times 5 is just negative 40, so yes, that is a possible answer. So we only have 3 cells that can be a solution. So we have this one, and this one at the bottom.